Okay, so we're going to talk about scientific notation. Okay, and what scientific notation's purpose is to like, instead of looking at really big numbers and like losing the millions and billions and trillions, we can keep track of it using exponents. Okay, so circle the words that complete the words to complete standard and scientific notation. So most numbers that are in blank notation, these numbers blank exponents. So most numbers that you see are in standard notation, standard, and they don't include exponents. Numbers in blank notation are written in the form of 1 to 10 that is multiplied by a power of 10. These numbers blank exponents. So in scientific notation, they're written with a like a multiplier from anywhere from 1 to 10. And these do include exponents. Okay. So for example, here's, instead of looking at this number, which I don't even know what to call this number, here's millions, here's billions, here's trillions, and then I lose it. I don't remember the names of these. So instead, we just say 8 times 24, 8 times 10 to the 24th molecules, right? Here, we're going to do the same thing. And all we're doing is this 24 here represents how many places I had to move the decimal, okay? So for example, if you count, and I'll count by threes, we have 3, 6, 9, 12, 15, 18, 21, 24 before we hit that 8. So if you notice here, this 8, this 8 here is this 8 here. And you're really counting how many decimal places you're moving over. So that's why we have that 8. Okay, so for this one, you're going to do the same thing. Notice it's going to be a 3 times 10 to the, so you can already write that down, right? You can already write 3 times 10 to the something, okay? And I know it's going to be meters, so I'm going to write meters. So here, I'm going to move this decimal all the way this way, and I'm just going to count again, and you're going to notice a difference. So I'm going to count by threes again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is going to be to the 10th, but here, this is to the negative 10th. Now, this is the first time you're really experiencing negative exponents, but a negative exponent means it's going to be a smaller number. Negative exponents, it's going to mean that it's a smaller number. So this guy here means negative exponents means a smaller number. Okay, a smaller number. That's why this is a really, really small, like, I don't know what place this is, right? I know tenths, I know hundredths, I know thousands, I know 10,000s and 100,000s, and then I lose it. Okay, so just know that when you're dealing with a negative exponents, your brain should think small number. When you're dealing with these positive exponents, you're like big number. Okay, so go ahead and finish these. Go ahead and try these. I'm going to pause the video for you. Pause the video and come back, and then let's check these together. Okay, now that you're back, let's check these. Now here, because this number is a big number, I'm going to expect that this exponent is positive. That's what my brain is saying. And similarly, this is going to be a small number, so it's going to have a negative exponent, right? So, so this first number, I already know it's going to be 4 times 10 to the something, right? Because you see my 4 right there. That's my digit. And then I'm still going to write the word stars because we're still dealing with stars. And then I'm going to count by threes because it's just easier. 3, 6, 9, 10, 11. So this is to the 11th. Okay. And I think, oh, that number is supposed to be really big because that's a positive exponent. I look over, check. Same thing with this guy. Now here, the difference between this problem here and these is that we only have one digit with a bunch of zeros, one non-zero digit with a bunch of zeros, right? So here we actually have a 15, right? So, but here, if you remember back in our definition, it has to be the numbers 1 to 10. So what does that mean you're going to do? Well, over here, I'm going to write 1.5. Because again, you just said that I had to do it between 1 to 10, and 1.5 is a number 1 to 10. I can't use 15. That's not scientific notation because the number is not from 1 to 10. Okay, not from 1 to 10. Okay, so now I'm going to count how many I need to move to get to that 1.5. I want to get my decimal right here between the 1 and the 5. Okay, so I'm going to count. So I'm going to count by threes again. 3, 6, 9. Okay, so this is going to be times 10 to the 9th. And then this is hours. And then let me check my answer. So when I look at this number here, because this is positive, I think, oh, that's supposed to be a really big number, but it's not. So I need to make this a negative answer. Otherwise, that's going to be a lot of hours versus a very small amount of time. Very good. So there, negative. Okay. Next little part. So fill in the blanks to describe the parts of scientific notation, then fill in the box with an example number. This is the number that's greater than or equal to 1, because remember, it has to be from 1 to 10 and less than 10. So notice it's got to be less than 10. Got to be less than, can't be 10. We can't have a 10 right here. We can't have a 10 here. Okay. And this is a power of 10. And it can be positive, it can be negative, or it can be 0. Power of 10 and negative. Okay. So then you just fill in an example. So I'm going to fill in, I don't know, a fun example. 3.75 times 10 to the negative third. Okay, so things that you should already know that you're thinking, you're like, okay, that's a number 1 through 10, check. That could be negative, check. And earlier she said that negative exponents mean this number is going to be small. So this number isn't 3.75. This number is going to be smaller, right? My decimal is going to move over here because it's going to be a small number. Okay. Okay, so now we're going to fill in these blanks to show how calculators display scientific notation. Instead of writing the full power of 10, the calculator uses the symbol E, and I'll show you that in a second. Okay, and it's a capital E, which stands for a power of 10, which stands for the exponent of a power of 10. Okay, so really quickly, so let's do this really quick. So 1.42E9 on a calculator, pretend this is, like on a calculator screen. I'm going to pretend to draw my little calculator with the little buttons, right? So that's what the screen would say. It would say 1.42E9. That actually means 1.42 times 10 to the 9th. So if you look, here you have your 1.42, and then here you have your exponent of 9, but over here you have times 10 to the, and here you just have an E. So really quickly, let me show you that. Oops, wrong thing. My calculator is gigantic. Let's see, let's make that smaller. Okay, so let's put, I don't know, let's go like 3, I gotta do a big number so it knows that I want it in calculation, times 489. I'm just gonna make up a number. There you go. Oh man, it gives it to you. So it actually gives it to you not in scientific notation. That's interesting. So a regular 4-function calculator would have given you like 1.5 times 10 to the blah, blah, blah. So apparently this calculator will hold a bunch of digits. The reason why your calculator will show it to you like this is because it doesn't have, like on the calculator screen, it doesn't have all this space. But this is a computer, so it's going to have as much space as it wants, right? Okay, let us continue. So complete the steps to show how to convert a number to scientific notation. First, we begin with a number in standard notation. So we're we're going to figure out how to do this from back and forth. So you'll see how to go forwards and backwards. Okay, and then you're gonna, just like we did over here. So we start with a number in standard notation. And then the very first thing, if you notice, I wrote that 1.5. So you're going to add a decimal if necessary. It'll make sense in a little bit. And then you're going to move the decimal to get a number greater than or less than 1 and between 1 and 10. So here, this was really, really small, and then 1.5. So I put 1.5, right? So here it says you're going to move it. And then if the number is greater than 10, the number is greater than 10, you're going to move that decimal in a certain way. And the number is less than 1, then it's going to be this way. I'm not going to tell you this because this will make sense if you just hold on to the fact that negative exponents means small numbers and positive exponents mean greater, bigger numbers. So here they want you to memorize like a trick of left or right, and I don't want you to do that. Okay, so then write the number from part C, the 1.5 from earlier, without the trailing zeros, without all those zeros, okay? Without all those zeros. Notice we didn't write 1.500000. We just wrote 1.5. And then we're going to determine the exponent by counting the places. Exponent by counting the places of the decimal the point moves. So remember when we were counting, like up here, we were counting 3, 6, 9, so on and so forth. Exactly. So multiply the part by 10 raised to that exponent. Okay. So here, you're just going to try it. You're just going to answer these questions. So are you going to move the decimal point to the left or to the right? Here, we're going to move it to the left, right? So that we can actually get there. I actually don't want you to answer this again, because it's almost like they're telling you to do a trick, and I don't like tricks. Here, I do want you to, because the number of places is going to tell you your exponent, okay? So how many places did you need to move this? So here they did 7. So count 1, 2, 3, 4, 5, 6, 7, right? 1, 2, 3, 4, 5, 6, 7, right? And then the exponent is 7, right? We need this. We need to know the number of places because it tells us our exponent, and then scientific notation. So now that you know this, can you try these two? Pause it, pause the video, and try these two. Okay, so here, when you're doing this, you are now going to move this decimal. So we're going to count the decimal places. Here it's 2. If you look at what number we are using, now this is going to depend on what, kind of like what your teacher wants in terms of this. So if there was a lot of digits like this calculator, remember there's all these digits here, there's all these digits. I don't like all these digits. So I'm probably going to give you like 2 places after. So I would round this to 1.47 times 10 to the blah, 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 right? So here I go. So I'm going to put this as 7.15. It is going to be 2 decimal places, and we get 7.15 times 10 to the second. Similarly, this one's going to be, I moved it 5 places. This is going to be 3.1. I moved it 5 places. And then you should be saying, hey, Ms. Johnson, you made a mistake. That's right. Good. I'm glad you figured that out. So this is going to be 3.1 times 10 to the 5th. Now, did you find my mistake? So here, this indicates that this is a really big number. But here, this indicates that this is a big number as well, and this is not. So what was my mistake? My mistake was that I should have done a negative. So there you go. All right, I'm gonna make another video to finish this off. Have a great day. See ya.